episode of Detection Dispatch, the hub for all things detection engineering. I'm Alex, hosting all the relevant DE discussions, exploring some of the hottest topics in the field, which, if you notice, not really much talked about, not many common forums to come in here and talk about a lot of the things that we talk about here in Detection Dispatch. So if you enjoy our content and you want it to be delivered to you piping hot every 2 weeks, please subscribe to our email list and join us right here live on Zoom bi-weekly or catch the replays on our YouTube channel. On our last episode, we had a really wonderful discussion with Michael Monti. We went in on cloud security detections, which recent studies should be a wake-up call for a lot of SOCs out there with a cloud footprint to secure, which is most, I would say. An IR study shed the light on a lot of these cloud security modules like GuardDuty, GCP, Azure, all reported little to no findings against 32 common attacks that were tested against. If you didn't catch that episode, I will link it right here in the chat for you. And what we've got prepared for this week is a very interesting topic, very, very key, around the life cycle of the detection. That will be episode 20. Very thrilled to have a very special guest, also second time guest of the series and a fellow gal in the DE world of cyber, Christina Westfall, one of our very finest detection engineers here at Anvilogic, cooking up detections, managing the life cycle of many detections for our customers. So I'm very excited for Christina putting all of her thoughts together in how the Anvilogic Forge does this thing. Now, Andrew Van Vliet, I'm going to throw up our primary task as a DE engineer, which, by the way, also very excited. In a couple of weeks, May 20th, we're going to have Andrew Van Vliet join us here on the show. So stay tuned for that. But when it comes to the two primary tasks that DEs have to do, they've got to accomplish threat detection. They've got to identify when an event is integral to an attack technique, when that occurs in their environment, right? If and when it does, classify it, of course, as malicious or benign. Both tasks must be done in order to effectively do threat detection, detect an attack. There's a whole life cycle around this, right, that happens to ensure many aspects of it, many different phases of it, visibility, the tuning, the testing, so many of it, and we're going to talk about it. So Christina, we want to hear from you, right, as our finest, right, one of our finest DEs responsible for maintaining the life cycle of so many detections in the armory, right, for our customers. She's got a really great outline that she's prepared. And we're going to hear from the source. So Christina, thank you so much for joining us. I will turn it on over to you. And I have maybe some questions here and there if we don't get to some of these things. So please feel free to take it away.
So let's talk about today's agenda. I'm going to go over just why detection engineering, some of the motivations behind why we do what we do. And then we'll take a look at the detection life cycle, kind of go through just, some of the considerations we have throughout that process, look at writing a couple of detections and when we generate our EOIs and what we do with that. So let's take a look. So I realize that I am probably preaching to the choir here, but I do want to start out with kind of the why behind what we're doing here. And to sum it up in a single sentence, we want to detect threats as early as possible. This phrase, prevention is ideal, detection is a must, has been around for so long and is said so often, I have no idea who to attribute it to. If you know, please let me know. But really, this is what we're trying to do. And so zero trust architecture, which I know is everyone's favorite buzzword. One of the pillars identified by the U.S. General Services Administration is visibility and analytics. And so a detection engineering program fits into this perfectly. So of course, we're going to strive to design our system securely. We're going to strive to put secure practices in place. But we also want to find out a breach as soon as it happens, as early as we can, and not too much later. So before we dive into the life cycle, I just want to do a brief overview on some Anvilogic detection engineering perspective. If you joined us in the past, this may look familiar. This is the David Bianco's Pyramid of Pain. And so this visualization just really demonstrates the mindset behind writing quality detection. Our most valuable detections are going to be at the upper end of the pyramid here. And, the tracking IOCs like hash values and IP address. Hash values, IP addresses, and domain names. Those IOCs, they have their place. I'm not saying there's no value in tracking them, but as far as what we aim to do here, we're really focusing more on the upper end of the pyramid, to have more valuable detections.
Christina,
So
we didn't catch the screen share.
Oh, I am so sorry. I'm so sorry. Give me just a second here. How's that? Do we have it now? Okay.
Yep, we have it now.
Sorry about that. Promise I know how to computer, everybody. And so just again, the pyramid of pain here. So really the whole idea is that for threat actors, as we move up the pyramid here, it's more difficult for them to change their approach when we focus our detections at the top of the pyramid here. So this is really where we're finding the most value. And so our aim is to generate events of interest at times at a very granular level, and maybe not quite as granular as change directory commands, but we're not necessarily that far off either at times. So we're going to be looking at some example threat identifiers today, and I want to stress that many of these are not a direct comparison to what we would think of as an alert that would be viewed by a SOC analyst. These are warning signals that we're bringing up. So with that being said, let's talk a little bit about the life cycle and development of a detection. So Ali Mellon from Forrester wrote about the detection, response, and life cycle, comparing it to the agile model of the software development life cycle. And a really central component of the model is continuous testing. And so it was really great to see this. She published this blog in July 2023, which is about a year after I joined Anvilogic. And, she really hits the nail on the head here. And like these practices are just have already been in place at Anvilogic. So it's nice to see an outside perspective that affirms that, kind of what we're doing here. The whole process. And so with a goal of detecting threats as early as possible, our first step when creating a detection is to figure out what we want to detect. And I just can't say enough good things about our in-house threat research team. They gather the relevant intelligence and distill it down into what I need to know, and give indications of severity that make prioritization of the content much easier. So whether it's a new vulnerability that's just been announced, or insights from breach reports, they bring me actionable information. And that drives a lot of our content development. So sometimes it's techniques also that our red team has come up with. These may not necessarily be public yet, but the whole thinking is that they can figure out how to do this. Somebody else can probably figure it out too. So depending how the technique is executed, the relevant log sources are going to make a big difference on how we go about finding, this information, whether it's cloud, application, endpoint, what have you. So if we're not getting the right information, how hard would it be to start getting those logs? Is there a configuration change I can make that's going to bring more visibility into what's going on? If we need to find a needle in a haystack, then we're going to need to search through some hay, and logs are going to create that hay for us. So we may have an idea of what we want to detect, but really before writing the detection, wouldn't it be great if we had a way to know that we're able to find exactly what we want to find? So we don't always have a publicly available proof of concept to work with, but whenever we are able to test out an exploit in our lab, we're going to do that really usually before we're developing a detection. So that gives us something that we can start testing our logic against as we're developing it. So to go back to that needle in a haystack analogy, we're basically just putting needles into the haystack, and making sure that we are finding them. Some of our testing we do manually. We have a team of exploit engineers, so they'll remote into a lab, hands-on keyboard work, that kind of thing. And so that's the path that we'll take when we're planning to write a detection for really specific components of an attack. We also want to document how the test was performed, and any considerations to be aware of in the environment. So in this example, we have a screenshot from a technique that was used, and then we'll have a link as well to shows us exactly where, okay, here's the log. And then we can start writing the detection kind of based on that. Now, for a more elaborate testing, I showed you a very simple test. It was a one-liner. That's pretty easy. But with adversary emulation, this can get very complicated. It can be very time-consuming to run these tests. So automation is really a lifesaver for us. We have this internal tool called Stormbreaker that I've got pictured here. And that's going to allow us to emulate adversary activity. So we can build out a sequential attack model. And this is based on observed threat actor activity. This would be so time consuming to do manually, to do it hands-on. I can set this up with a few clicks, tell it to run, and then I've got my events generated for me. So when it comes to writing the detection, we know what we want to detect. We've executed it in the lab. The logs are there. So what's next? And this is really kind of the fun part. I like to think like an attacker. I like to think, all right, this is one way of doing it. Are there slight variations of how I can do this that I could sneak past, a detection? How might I do that? Is there, just a little different way that I can execute this same attempt, and avoid a detection? Obviously, with the goal of writing a better detection that's going to catch it. So I have here an example. This is from Palo Alto, and they had a whole long report about this breach. This is just one of many techniques that they demonstrated. And so they have this command line here where when the Windows event utility was used to query some specific events from a security log. And so they were targeting privileged logon events. So I've got an idea of what I'm looking for. And so I'm saying, okay, well, that's straightforward enough, right? I want to look for a process name like winEventUtility.exe and the command line containing QE security, just like I see here on the first and second line. So that's a good start. And that's great if what I want to find is this specific event. But I have to think, okay, are there other ways that I could achieve this same exact goal? So one thing we do, we read the documentation. So Microsoft tells us, okay, yeah, you can use QE. You can also use query events. Is it possible to do it that way? Yeah. Is it likely that they're going to use it that way? I don't know, but I want to make sure that my bases are covered either way. So really, this is where I start asking myself just kind of, what if I do this? What if I rename the executable? What if, I use an alias, or what if you use the full name here? So this is a slightly improved version of what we've got. So I'm still looking for the command line, but this time I'm throwing in a couple of other options. I've intentionally added spaces in between my single quotes here. So I'm looking for these showing up by themselves, not in mixed in with a longer string. And then also just with a simple regular expression, we can just do matching on this to make sure we're getting this exact string kind of all in a row. And we're doing things like making sure we're accounting for extra spaces that are thrown in on the command line, and that sort of thing.
Christina, we had a comment in the chat, a question about, is
Sure.
Stormbreaker tool similar to the Atomic Red Team or like MITRE's Caldera or like Pantera?
Yeah, so I have experience with the first of those, with Atomic Red Team. So I can't make a direct comparison with the other tools. But Atomic Red Team is a major part of what we do with it. We leverage it, within Stormbreaker, to the point where I can check off a whole bunch of Atomic Red Team techniques and use them when I'm staging my attacks there, or I can run them as one-offs if I want, as well as anything that's on GitHub that's publicly available as well. But yes, Atomic Red Team, really love the stuff for Red Canary, and that is a big part of what we do with Stormbreaker.
Mm-hmm.
All right. So once I have logic, this is where the platform, as far as the detection engineer goes, this is where the platform really, I really start seeing the value of it. So the next step is to create and deploy my detection, which the platform makes just so easy for me. So whether I'm using Unified Detect, like I have here on the left, this is kind of a drag and drop rule builder. And this is just wonderful, very easy to use, very quick. Or we have more traditional queries like we have on the right-hand side here. So whichever way I'm going about it, creating our threat identifier is really pretty straightforward. We can also add a bunch of metadata to any threat identifier that we create. So an explanation of what's going on, some screenshots and references that we have from all the research we did when we were looking into the attack in the first place. We also have the option to add some ratings that are going to affect our risk scores that our data science team can leverage later. So great. We've got all of these events of interest. but what is the value in detecting something as granular as some of these examples that we've seen? So let's talk a little bit about, where do we use these events of interest? So we have a hunting index, which functions as a really important piece of our detection engineering approach. The index ingests our warning signals, those individual, really granular detections that would otherwise be noisy alerts. And so the index can help to provide event correlations. Sorry, do you have a question or anything? Okay, sorry, I thought I heard something. So this is this puts us in a proactive and not a reactive state. So we can conduct targeted hunts as we've already normalized and vetted the data. The normalized data is going to enable us to search against different domains. So threat scenarios, this was one of the first things when I was first learning about Anvilogic that I saw, and just kind of, the light bulb went off in my head and I said, okay, this is really great. So our threat scenarios are where we take those granular detections and we can chain them together to build sequential behavioral-based detections. So you don't need to know any code to create a threat scenario. You just pick the threat identifiers you want to put together. You can set a time frame for different stages of the attack. And then you let the correlation engine do the heavy lifting instead of doing all of this manually. So earlier when we looked at Stormbreaker, if this looks kind of familiar, our scenario builder, it's kind of by design. In the same way that I'm able to build an adversary emulation. It's really kind of similar to how I'm building a threat scenario. And so back to the idea of continuous testing. Once I build that scenario, we can head right back to Stormbreaker and validate that our threat scenario is detecting as expected. And when we're testing at this level, that's where the automation, again, just becomes very helpful because, if we make any mistakes in the process and we need to run something again, manually, this could take half a day, or more. But otherwise, it's just, making a few changes in Stormbreaker, running it again, and, going from there. So we mentioned before the concept of the life cycle for detection. And one of the stages that we mentioned was monitoring. And this is another area where I think Anvilogic really shines. Tuning the rule for one environment, that's challenging enough. At Anvilogic, where we serve different types of environments, that becomes even harder. So if you think this sounds like the perfect use case for machine learning, like you're absolutely right. Our data science team is able to produce these tuning insights, and by analyzing the EOIs and patterns that arise, they're able to make really specific suggestions for improving the fidelity of a use case. And it's just so easy to implement the suggestions that they give us. So this is kind of ongoing monitoring and feedback mechanism. And that's going to ease a really major pain point for us. And so I want to finish off by touching also on hunting insights, because I think this is really cool. When we highlight some eyebrow raising activity and bring it to our attention, kind of bubble it up to the top, we can get a better look at one EOI in a sea of, thousands, more than thousands, something that might deserve a closer look with information about why the EOI has been raised and some guidance on how to proceed further, which really brings us back to kind of the why behind we do this. Why are we doing detection engineering? Well, we want to detect threats as early as possible, and this helps kind of drive that home. And so I also want to plug too the Detection Armory, which we recently released. So if you're interested in seeing more threat identifiers like any of the ones we mentioned today, we have over 500 of them out. I think we have more coming. These are in different rule formats, different log sources. So please, at your leisure, please go check those out if you haven't already. And that is all from me.
Really great content, Christine. I had a couple questions around the decommissioning of the detections.
Yeah, let's talk about that.
When would you say, or how do you go back and look to see when a detection should be decommissioned, or how do you know one needs to be improved? How does that go about?
So let's start with decommissioning, which honestly, we don't do super often, more so in terms of if something significant has changed in the way logging has happened, in a repository, maybe we'll decommission, in that sense. But really, when it comes to the logic itself or what the aim of a detection is looking for, like let's say that something has been fixed by a patch, there's still value in detecting it because, as everyone here knows, keeping our systems patched and up to date, in a perfect world would happen right away every time. But maybe a system comes online that hasn't been patched and, that can get hit. So we always still want to detect on those things, even if it seems obsolete. I know sometimes that there are some requests that we've had, some tickets have worked where, you look at a vulnerability and it's years old and it's like, okay, why would I detect this, right? This is old information. But really, you look at organizations out there, And how many are still running XP, on some systems, like it's not like everybody updates as soon as the new hot thing comes out. We have to serve, all of those systems. So
Yeah, there
and
are definitely people out there running XP for sure.
still happens. And so the other side of the coin, so you were saying like feedback and tuning and that kind of thing. And so
Mhm.
that's where our data science team is really helpful. So sometimes the tuning insights that they're making, those can be very specific to a particular environment that really wouldn't apply anywhere else. But other times they can bring us some really interesting information or some suggestions and say, hey, we're seeing a lot of this. What if we added this? What if we changed this, tweaked this, a little bit? Would this still work? Is this still going to catch what we want it to catch, but not catch all of this other stuff that we're seeing as well? So this is this is a way that we really leverage the data science team.
Yeah, I obviously testing and with the question in the chat, Caldera and MITRE and these tools out there obviously is super important to test the accuracy of the detections. And the way that I've seen it across the industry is like I see it in three main buckets when it comes to testing. Obviously, there's the kind of regular stimmus, right? To check if the detections still trigger like unit-based testing, right? To see if it confirms whether the vendor payload is still what it is, right? Is Windows 7946 with the parameters, does it still populate today? Because then that will trigger the downstream detections. But then I also see, and what I was a part of in another life is this dimension around like attack simulations.
Mm-hmm.
And that is when like adversary simulations, if you're a part of a project, then you have the capability to perform attacks against an environment and a really against the way that you're uniquely set up and allow you to build, pretty good data sets to further build your detection, the very threat oriented kind of a strategy. I participated in things like the MITRE Ingenuity evaluation program, where a lot of vendors in this space would test kind of their rule sets against threat attacks. Turla was last year, Wizard Storm, Sandstorm, Wizard Spider, and they're given an opportunity to really, to kind of tune and build detections, and then be trialed and tested, which honestly is good for the industry as a whole. But then there's also kind of a third party statement of work, bill of material where a purple team will periodically execute attack scenarios, give you a report, tells you what you're missing. So all great strategies, right, to future proof your detection systems. Curious if anyone else has tried any of these approaches. What
I can
query
see a
language?
question.
Yeah.
Yeah, which query language is in the logic section of Stormbreaker? So in Stormbreaker, actually Stormbreaker, you don't need to know any code to use it.
Oh,
So no query language necessary.
great.
The whole kind of idea, behind the project was, okay, if we have a tier one SOC analyst who wants to run some tests and isn't
Yeah.
comfortable doing it, the hands-on keyboard work, we wanted to have a tool that was as easy as just going in, selecting what you want, whether it's by MITRE ID or by, atomic red team test, or by a use case that we have existing in the platform. Any of those ways, and then just easily running it. So
And Stormbreaker is not available for folks. It's just
this is
specifically
an
a
internal
Forge.
tool that we
This is
use.
what the
Yeah,
Forge team
yeah,
uses.
yeah.
I see. Great. Any other questions in the chat? No.
So the detection is auto-generated. Well, no. So what Stormbreaker we use Stormbreaker to test. We use Stormbreaker to run simulated tests, to simulate adversary activity. And so the reason that we do that is so that those logs are generated, and so that when I'm writing my detection, when I'm developing my detection, I have something to test against right away. So I can say, kind of at every step as I'm refining my logic, okay, I know the logs are there. Did this find it? Yes. Okay. But it found all this other stuff. What can I add to it? So I'm really only finding just what I'm looking for, and as we continue to tweak it, so the detection is generated still by us, still by humans. So, but a lot of the testing we're doing with automation. Thanks for the question, Josh.
Yeah. Seems like Stormbreaker's a hot topic, or any tools really that can make our testing better. And I guess we can end with the software development life cycle. Ali Mellon is exploring it, and she's bringing it up in more and more conference talks. This idea that detection engineers can also find a lot of success by following the software development lifecycle, just like how they build, successful applications. Detection engineers too can also take that approach to carefully consider how they're building and maintaining their detection logic. Snowflake at Snowflake Hater Dust, I know he's very open about their process and their detection engineering process. They follow it very closely as well. I'll link to his blog post in the chat as well that you guys can take a look. Now, when we think about what we're talking about here, obviously the DE has two primary tasks. Van Vliet talks about this quite a bit. And by the way, stay tuned. He will be joining us in a couple of weeks on May 20th following RSA to talk a little bit more about this. So very much stay tuned for that episode. But two primary tasks that we have to do, obviously, is identify when an event, right, is integral to an attack technique, right? And of course, classify if that event is malicious or benign. But there's an entire life cycle, obviously, that happens around this, and this whole thing to ensure that, well, one, obviously, we're getting the visibility, right, of the attack of the technique in question, but also, the rule, the detection, to ensure that we're getting notified about it, and probably a life cycle in and of itself around the tuning and the testing to ensure that it's creating an accurate result, right? Thank you so much for joining us, for putting all of this together. The Sandstorm tool, super, super cool to test our detections. Now, a couple of updates or a couple of announcements for Detection Dispatch the next coming weeks and what to expect. We're going to be skipping the 425, the April 25th session, and we're going to come back live from RSA with a deep dive with Ryan Fitch, an SVP leader that's going to walk us through their strategy to adopting a multi-data lake strategy, the challenges, what kind of telemetry that they're able to capture today, what kind of use cases that they've got running in their threat detection program. You're going to hear it from the source, from SVP managing and securing the guardian of a really large enterprise security operations center with hundreds and hundreds of events and a pretty robust and large SOC. So join us at RSA. I'm going to be projecting live from RSA the week of May 9th with Ryan Fitch. Thank you so much, everyone. We'll see you at RSA.